All right, so we're going to continue 4.1 trig identities. This is part 3, kind of going through some advanced techniques that can be used to make these a little bit easier sometimes. So this is the third one, talking about factoring. Sometimes factoring is going to be a really useful strategy. Factoring can kind of help us find a quicker way to get something done, or maybe even unlock it for us. So in this case, we can factor by greatest common factor. Each of these terms has a cosecant squared in common, so we can factor that out. That leaves us a 1 here, minus, and we factor away that cosecant squared, that's just going to leave us with cosine squared. Yeah, so then once we get to this point, hopefully we can kind of notice that, well, we've seen this one a few times, even in the different parts here. This is equivalent to sine squared. So I have cosecant squared times sine squared. And we've simplified this a couple times, right? Cosecant squared is the reciprocal of sine, so it's going to be sine 1 over sine squared times sine squared, which cancels out, leaving us 1. Again, this isn't the only way to have done this problem, but it's certainly a nice one, certainly one that can give us an answer pretty quickly. Let me go ahead and clear this, and let's just kind of explore another way that you may have thought about this problem. So another way that I think would be pretty common here would be to think about these all in terms of sine and cosine, kind of our baseline idea if we don't think of something else. So 1 over sine squared minus cosine squared times, well, let's go ahead and write that, times 1 over sine squared again. And so then we end up with, well, combine some things together. This way is pretty much always good. It's not like you go wrong doing this for the most part, but it may not give you the answer in sort of the fastest way. Like, so we're already kind of 2 steps in. We haven't really quite gotten there yet, but we're close. These actually already have a common denominator, which is nice. So we can put those together. We end up with 1 minus cosine squared over sine squared. And here's the point where we do need to notice that Pythagorean identity again. So 1 minus cosine squared, right? We can replace that with sine squared. So we end up with sine squared theta over sine squared theta. And those simplify, those divide and equal 1. So, writing things in terms of sine and cosine works. This was just a little bit longer. Sometimes finding that factoring and working that way is just a little bit faster. Yeah, just a little bit nicer. Anyway, let's go ahead and move forward. Let's talk about some more factoring. So here is some more factoring that we can do. We have some difference of squares factoring that we're going to use in this problem. So we're going to be working again with the left side. This one's more complicated than the right. This denominator is what I really want to focus on. I have tangent squared x minus cosine squared x. This is my a squared minus b squared. I can factor that out a little bit, right? We always know that this factors as a minus b times a plus b. This is our basic difference of squares or conjugate pair factoring. So I won't mess with the top. I'll leave that as tan x minus cotangent x. And then my denominator, that's going to factor as tangent x minus cotangent x times tangent x plus cotangent x. And hopefully you can see what's going to simplify out here, right? We have a tangent x minus cotangent x in the top and the bottom. So we actually end up getting some nice simplification here in the way of doing this problem. So now we end up with just tan x plus cotangent x. Now, that doesn't make this problem easy. It just makes this problem a little bit easier, where there's a little bit less going on. What else can we do here? Well, there's a few different things, few different options to us, but I think our best bet is to go back to sine and cosine and try to put these together here, right? So I'm gonna work on this. I'm gonna do a little bit of abbreviating. So I'm gonna make s equal to sine and c equal to cosine, just to make this look a little bit shorter. So I'm going to be ending up with 1 over, so tangent is sine over cosine, and cotangent is cosine over sine. So I know I got to get a common denominator here. So I'm going to be multiplying this one by s and this one by c so that I get sine times cosine on the bottom and the top. So let's go ahead and write out what that looks like. This is 1 over sine squared plus cosine squared over sine times cosine. Fortunately, we have uncovered another Pythagorean identity to make this a little bit nicer. This right here, sine squared plus cosine squared is equal to 1. So now we're at 1 over sine cosine. Well, reciprocal this, right? Instead of dividing by 1 over sine cosine, I can actually just turn this into its reciprocal, which ends up just giving us sine x cosine x, which is what we are trying to get to, right? That's what we're trying to get to. You know, this factoring, is this the only way to do this problem? No, we could have done pretty much the same thing that we did down here with some more complicated expressions, sine squared, cosine squared, ending up with some higher powers. But in this way, we did reduce things a little bit, make it a little bit simpler right off the bat before we jump into that. So this factoring can kind of make it a little bit easier if we can kind of factor something out nicely and reduce a little bit. Anyway, let's go ahead and clear. All right, and then last one here, last sort of technique is this idea of conjugates. So a plus b, a minus b. When we multiply something together like this, we end up not getting this middle term. We end up just squaring both of them, difference of squares sort of situation. That's pretty useful. That's something that can really, really make this whole idea work so much better for us. So sometimes multiplying by conjugates is really the way to go. So let's just kind of take a peek at what's going on here. We have 1 minus sine x, 1 plus sine x. These are actually both conjugates. What I'm going to do is I'm going to focus on my denominator. I would really love the denominator here to just be a single thing. So I'm going to multiply by the conjugate of my denominator. I'm going to multiply by 1 minus sine x. Do that on the top and the bottom. Okay. On the top, I'm actually multiplying the same thing, 1 minus sine x times 1 minus sine x. I can use an exponent to express that, 1 minus sine x squared. And in my denominator, when I multiply this out, I actually just end up getting 1 squared, which is 1 minus sine squared. And the reason this was so useful is because now this is a Pythagorean identity. This is simply equal to cosine squared. Cosine squared. Let me actually just reduce this. Cosine squared. Let's write this out. Well, this is going to get a little bit trickier because I do have to multiply this out. I do actually have to multiply out 1 minus sine x times itself. So let's just do that on the side here. 1 minus sine x times 1 minus sine x. So we're doing 1 times 1, 1 times minus sine x, minus sine x times 1, negative sine x, that's going to be plus sine squared x. All right, so combine some things together here. We end up with 1 minus 2 sine x, 2 negative sine x's, plus sine squared x. Okay, so this is what this numerator reduces into, or multiplies into being. 1 minus 2 sine x plus sine squared x over cosine squared x. Well, all right, so let's go ahead and take a look at this here. Because I have a single thing on the bottom, I can go ahead and distribute this division on through. And that's what I'm going to do here. I'm going to erase some things, kind of give myself a little more space, move some things over. So I'm going to go ahead and slide this over here. Let's do this. So now I got 1 divided by cosine squared x. Got that. Minus 2 sine x cosine squared x plus sine squared x cosine squared x. Okay, here is a place where this whole time we've gone into simply manipulating one of these things. Well, that's not gonna be you know, I'm still gonna only manipulate one of them, but I really gotta think about this. I really gotta think about what happens here. Really gotta think about how this kind of comes to be, right? Because when I multiply this out, I should end up getting secant squared x, right? Because I'm gonna multiply this out. Just gonna kind of quickly multiply this out here and just sort of see if I can figure out what's going on. So again, this is just the idea of like knowing where I need to get to see if I can make it work. So secant x times secant x is secant squared x. And then I have secant x times negative tan times secant. Those are going to be the same product. So we're going to get negative 2 secant x tangent x. And then we're going to get plus tangent squared. So when I multiply this out, this is what I get. I need to be able to see how these two things are connected. I think they're connected, right? This right here is this term. Secant squared x is the reciprocal of cosine. So this one is secant squared x. This one right here, a little bit harder to see, but if I break this up strategically, I end up getting negative 2 times sine x over cosine x times 1 over cosine x. Right? Here's my tangent. Here's my secant. Negative 2 secant tangent. That's what I get. Negative 2 secant x tangent x. And then here, sine over cosine, that's tangent. So that's plus tangent squared. So what I have here is now this actually factors. This actually factors into secant x minus tangent x to the second power. This is one of these things where we want to do most of our work on one side, but we kind of want to mess with the other side a little bit just to see kind of, all right, well, what happens with this? Can I expand it out? Like, or what do I need to try to achieve? And you can sort of see that they kind of meet in the middle a little bit. And we can demonstrate that this is actually equal to what we had just up there. This one's pretty advanced though.